All right, hello once again. Jeff Scott, formerly of Rankin Technical College. And as part of my YouTube channel, JPS-Jeff Teaches Programming, and in particular the YouTube playlist, Jeff Teaches Programming-Python, so far I've created approximately 25 or 26 videos. All right, and I've gone over an introduction to Python. I've gone over the keywords of Python, most of them. I've gone over the main data structures that are in Python, those being lists, dictionaries, tuples, and sets. And now it's time to talk object-oriented programming. I'm going to probably write a program in this particular lecture or this particular video, but just so you know, as I go on, I'm planning on doing, let's say 3 things with object orientation. 4. Number 1 is what I'm doing now, which is an introduction to object-oriented programming. Number 2, I'd like to go back and rewrite all 4 of the programs that I did. Again, the payroll programs, those being, one more time, all right, using sets, using dictionaries, using tuples, and using lists. Go back and rewrite all of those in an object-oriented manner, and there'll be a lot of overlap between them. So that'd be the second thing. Then third, I would like to go back and basically rewrite the entire payroll program from scratch with object orientation in mind from the start. Finally, I'd like to go back and write one more application, probably like a banking application, something people can understand, maybe a calculator again, I don't know, but banking seems to be a good one, all right, in Python. All right, and that's what we're going to do in this next section of code. All right, so there will be some kind of and I didn't write it yet, but why don't you watch me do that right now if you would. And that is, let's go out here and let's go out to github.com, and under my stuff, right now I've got for Python, I have the first one I did, which was Python keywords. Then we went and did Python calculator, which I guess I spelled wrong, 2, and guessing games. And we just finished with JP Scott, Python, BMI, and payroll. Well, that BMI and payroll was non-OOP. So let's make a new repository in here that we'll just call Python OOP for object-oriented programming. Okay, I'm the owner. Of course, it'll be public. And I'm just going to create the repo. And I'm going to grab this. All right, and let's just come in here and create a new folder out here on the desktop, and we'll call it Python OOP. All right, I'm going to come into here, and I'm going to open up and do a git bash here, and all I want to do in here is let's create the repository. So git init. Now it's empty. Now it's not. Okay, I could go in and try to do a git add dot, etc., but there's nothing to really add. So let's set up our remote right here. So I'm going to paste that in. All right. So we're adding our origin, and that's the Python, which I spelled incorrectly. Good gravy, Jeffrey. All right, let's go back and fix that. There is a thing in here for settings. I know there is someplace. In fact, let's just do this. Pyron. Good gravy, Jeff. Let's go back and let's rewrite this. So it'll be me, and we'll call it Python-OOP. Okay? We'll just do that. Create the repository. Do our git remote, which now will be correct. Go back to here. Let's remove this. which is spelled wrong, and I'll get rid of that repo later. Okay. So there's that. Now there's nothing in here right now except in, the Git folder that's got all the Git stuff in it. All right. Now I want to mention one more thing before I get started here, and that is, if we go out, you might have seen this already, but these are the keywords in Python. All right. Now let's take a look at what we haven't gone over yet. We have not gone over await, which we won't for quite a while. We went over all the rest in here. We did go over none. We went over everything in the second row. We did not go over class. We're going to hit that now. I think we went over everything else in there. We've gone over and continue for, lambda, try, as, def, from, non-local, while, assert. So right now it's await, class, and assert. And the async. So I think there's, and yield. I think there's 5 words in this list, all right, of about 35 words that I have not yet gone over. We'll go over class now. Later on, we will go over await, assert, async, and yield. All right. Now, what I want to do here, and I'll put these out there right now as I get them done. All right. But I'm going to go over a couple articles. Good, bad, and different doesn't matter, but this is the way I decided to do it. And the first one, this just came out recently. It's called OOP in Python, Key to Terms and Concepts, Part 1, which means there's more parts coming. All right, so this will be the first one that I'm going to go over. All right, and again, the URL I'll put right here in just a minute. And then I'm also going to go over this thing called classes in Python are very easy. And I've said this kind of thing before, but easy is a relative term, meaning what's easy to me and what's easy to you are probably 2 different things. All right, so here's the one. And I'll make this a little smaller in just a second. And here's the other one. All right, so if we look right here, and again, it's pretty big right now, but let's make the font size smaller. Let's make it about 28. It could be bigger, but I think you can all see that. So we've got OOP in Python, Guide to Key Terms and Concepts, Part 1. And classes in Python are very easy. All right, both of these have appeared on medium.com, which again, I would strongly suggest that anybody who has an interest in learning Python or any other programming language, all right, $5 a month, or if you pay annually, it's $50 a year. You get articles probably about 6 days a week and some really good stuff. All right, so let's start. I was going to do this one first, but I think instead I'm actually going to do this one. All right, I've read them both, but this is called Classes in Python Are Very Easy. And I'm literally going to come in and I'm going to use their example right here. All right, so what I'm going to do is I'm going to start by coming in, starting up, lost somehow here. But I'm going to start up Visual Studio Code. In fact, let's not even do it that way. Let's go into our new folder, Python OOP, and let's open that folder with code. All right. And the first thing I'm going to do is I'm going to create a file. And that file is going to be a little different than what we've been doing so far. So this is going to be called dog.py. Okay. This is the same one that they're doing in this article. All right, you'll notice class files typically start with a capital letter, where the other files we've been creating so far do not. All right, and I'm going to grab everything that's in here. We're going to go over all of it. Let me just do this. Whoops. Okay. Now, right now, if I run this, nothing's going to happen. All right? It's not going to show anything. And just to prove this to you, all right, I'll do a file, save all, and I'll run it. And you'll notice I get nothing. All right? There it is. Now, it's not that it's wrong, but what we're doing right here in this example, you see the keyword class. We're creating a new class. You can kind of look at a class as being a new kind of variable, but more than a variable, it's a blueprint. So what we're saying is when we create a dog, these dogs should have a name and an age. And this dog should be able to bark. And when you work with classes like this, what you end up passing in virtually all the time to different methods, I mean, a method is just a function that's inside of a class, is the keyword self. Shouldn't even say that. Is self a keyword? Let's look. Self. I don't actually see it in there. I thought it was a keyword. All right. And could I be wrong? I'm wrong more often than I'm right. All right. Now, there's a few things that are going to look a little funky in here. First of all, you'll notice we got the word class, which says that what follows here is a class. Now, this has to be capital letters. What we created here, did this have to be capital letters? No, not at all. So if we want, we can go back here. All right. Why it's giving me that stuff. Okay, fine, committed. Fine. Yeah. All right. There we go. We could go back in here. All right, we could go back in here and we could change the name. Let's just leave it the way it is. All right. But class names are capitalized. All right. So we've got a blueprint. Now, what's a blueprint? You all should know probably what a blueprint is, but kind of look at it like this. When I explain this, when I was teaching the classroom, this is the way I would always explain it. And the place that I taught out of for the last couple of years, I was at Rankin. They had me in a conference room because my courses were online. And if I looked outside the window of the conference room and looked to my left, there was a big field. All right, I don't know how many acres it was, but let's assume for a minute it was, I don't know, 100 acres, okay? And let's assume that a developer bought that field of 100 acres and decided that they were going to put a bunch of houses up in that field. And with the roads and the sewers and everything else, they said that in this 100 acres, they could put up, let's say, they were going to put up 40 houses. All right. And they had 5 different house plans. You know, they had one that was a ranch, one that was a 2-story, etc., that kind of thing. Each one of these house plans could be thought of as a class. It's a blueprint for what each one of the houses would look like. Each house that you create from the class would be what's known as an object. All right. Now, a couple things again. You start a class with the word class followed by the name of your class and then a colon. Now, this looks a little weird. This is how you initialize a class. What that means is this expects that when you go in and you create a dog, that you will pass in a name and an age. So these things right here are typically referred to as properties. So there's a name property and an age property. This right here, and I said this earlier, is referred to as a method. And a method is a function that is written inside of a class. All right, so, hopefully it'll make sense. If it doesn't right now, it'll make more sense as we go on. Okay, so let's just keep going here. So here's their explanation, probably done better than mine. First, we've got init, and that's underscore underscore init underscore underscore. As it says, this is the initializer method. All right. In other languages, it's called basically a constructor. As it says, it's called when you create an instance of a class. When you create an instance of a class, that instance is known as an object. The act of creating instances of a class off of the act of creating instance of a class and creating objects is known as instancing or instantiation. Self, as it says right there, self is a reference to the current instance of the class. You use self to access what's in the class, meaning the variables, or what I call them, the properties and the methods. Then you can go in here and you can start creating these. All right, so let's look at this. Hopefully I'm going to do this right. Okay, I think I can put that here and do that. Let's see if we get the output that they're talking about here. File, save all, run. And the output is Buddy says woof, Buddy, and 3. Where do we get all this from? Well, if you look right here, this right here, that. All right, what are we doing right there? Let's break this up. So first, we're coming in, we're creating an instance of the dog class. And it will be called my dog. Let's change that to Buddy. So we'll make this Buddy. All right, now that those will have to be changed to Buddy as well, but we'll do that in a minute. All right. So this we'll call the bark method of the dog class. Now again, since we changed this to Buddy, that means that everywhere we've got my dog, it'll now have to be Buddy. There. All right, so we're calling the bark method here. Here, what we're doing, because this is our whole program here, we will print the value of the dog name, which again is Buddy. Where do we get that from? Right here. Notice since it's a string, we'd have to put it in either double quotes or single quotes. Finally, we'll print the value of the dog age, and that is 3. All right, and I can create as many of these as I would like. I'm going to quickly create another one. In my family, even though the dog dislikes me, we have a dog, and they named it, don't ask me why, but they named it Olive. So I'm going to come in here. In fact, let's just grab all this. And don't worry if we get any errors because we're repeating stuff. We'll fix it in a minute. All right, so we'll come in here and let's comment out all of the first stuff that we put in here. Okay, so all this. All right, so now we'll come in and we'll create an instance and we'll call this one Olive. That's the dog's name. Don't ask me why. I didn't name it. It's not my dog. Olive equals a dog. The name will be Olive. And Olive is now 8 years old. So we'll call the dog the bark method. So we'll have to say Olive.bark, and it should come back and say Olive says woof. Then we'll print the value of the name. And we should have print Olive.name, which should print, if we did it right, Olive. Finally, we should print the dog's age. And notice that's 8. And that'll be Olive.age. Now, the order in which we do these doesn't matter. The order in which we print these. So if I wanted to print this last, like that, should still work fine. Just the order will be different when it prints it out. That's all. So File, Save All. Okay, so this was print the name, this was print the age, and this was print the results of the method. And we can pretty this up a little bit if we want to. So we could come in here and say print. All right, and we can even make this an F string. And we can say the name of the dog is like that. Whoops. Is like that. And then we can say, how about this? We'll say another F string, not a G string, another F string, and we'll say the age of the dog is and here we'll say the sound the dog makes is all right. And of course it's going to change this. So the output here isn't going to be Olive. It's going to be the name is Olive. I'm just going to get rid of that. And here it'll say the age of the dog is 8. And here, so we've got all that. The age of the dog is, let's say here, years. All right, so let's save this and run it again. Oh, didn't like my syntax, so we'll fix it. I must have park class dog. Okay, that's all good. Create an instance of the dog class called Olive. Olive equal dog. Olive 8 should be okay. Print the value of the dog's name. Print the name of the dog is Olive.name. That should be okay. Print the value of the dog's age. Print the value of the dog is Olive.age, years. That should be okay. The sound the dog makes is, well, it doesn't like something. It says go live is not defined. Did I somehow put that in there someplace? says there's no results, but it doesn't like something I'm putting in here. It's telling me I've got invalid syntax. Well, we know, and that's okay, we'll fix it in just a second. We know that the syntax has got to be in here, because this is what we changed. So let's see. Olive equal dog, olive 8. Let's do it like this. Let's see if this, let's see if we can debug it like this. So let's see if we run this, if we get any errors. Okay, so file, save all. Let's run it and see if we get any errors. Now, right here was giving us invalid syntax, so let's try running it again. Okay, looks like it's okay. It's not giving us any errors here. So let's go and uncomment this line. So we should just say here, if it works, the name of the dog is Olive. Well, it's saying it right there. File, standard in line 1. I've not seen this error before. Invalid syntax. Invalid syntax. Well, if it was line 1, it'd be at the top of my program. So it would be here. The name of the dog is olive.name. That should be fine. Did the same way here. Print buddy.name. The only thing is here we're making it an F string. Let's see if it doesn't like something with my F string. Let's see if that works. Now, this is my guess, okay, just so you know. My guess is that what we had in here is fine. Okay, but for some reason, again, I'm having a problem with my history. So let's do a file, save all. Let's get out of here. Let me bring this thing up. For some reason, this appears to clean up the history when I do this. I'm not sure why. Okay, if I do a 12 here, boom. All right. Normal termination. Let's bring this back up again. All righty. So you can see the whole program here now. The name of the dog is olive.name. Isn't that interesting? So it is the way that I'm printing that. It does not like that with this. Okay, it's not a problem. Let's go back and change it the way I mentioned before. So we'll put a plus here. we'll do it like that. Oh, no, that wouldn't be it. Let's see. See what that did. Well, it looked like that was in there. The name of the dog is Olive. Okay, so that works. All right, so let's change all these. All right, so we'll have the name, we will have the age, and we will have the sound. All right, so let's take a look. File, save all, let's run it again. All right, it's giving me an error, but I'm not worried about it yet. So the name of the dog is Olive. All right, it's telling me in line 31. Oh, okay, I know what the problem is. Okay, it's doing this. I have to let it know that I want the string value of this. There we go. That should fix it. Let's go down to here. And I cleared everything out. All right, so let's see what it's got now. There we go. The name of the dog is Olive. The age of the dog is 8 years. The sound the dog makes is Olive says woof. Okay? Just so you've got an idea of what we can do, etc. in here. I could uncomment this, and now we'd have 2 dogs. We'd have Olive, and we'd have Buddy. Okay? Again, not a problem. All right, let's go back. All right, now, when you work with object-oriented programming, there are a few hallmarks, a few key things that you've got to understand. All right, I don't know why they did it in this order, but they did. So this is actually, if you were going to have these 4 things, this is the one I typically mention third, but we'll say it first. Number 1 is inheritance. All right. Now, the way that typically genetic inheritance works is you've got a guy with a big nose who marries a woman with a big nose, and they have a child which will typically have a big nose. I know it doesn't always work like that, but the way genetics oftentimes works, it'll be like that. All right? Well, what the child can do is live with a big nose or get a nose job, basically. But it's not like the child can just take its nose, take it off, and put on another one. Oh, I don't like that one, try another one, etc. But with inheritance and software, that's kind of what you can do. All right. Now, what I want you to see here, when you look, is we're going to change. I'm going to keep all of this. All right, but I'm going to create a new file. So I'm going to come in here and I'm going to create animal.py. In fact, while we're in here, can we now rename this and make that a little d? There we go. All right, so in our animal.py that's right here, let's just go paste this in. Now, this isn't the way you're typically going to do it, in that we've got 2 classes in the same file. You can do that. I want to say that again. You can do that, but it's not often done that way. All right. Now, here we've got age. You know, we had the name, and we don't have. Oh, we have the age in here, and then we got a speak method. So what are we doing? We're pulling the name out because we're saying that all animals have a name. Okay? And really, probably what we would do is we would also pull out the age, but they're doing this to show you something. Okay? This is the init method for the age. So when you create an animal, you've got to give it a name. When you create a dog, you've got to give it a name and an age. But notice this word here. This super says, okay, before you go and do this code that's in here, I want you to call the init of my parent, which is right here. So in other words, animal will handle the name, class animal, and class dog will handle the age. All right? And even if it's making little to no sense to you right now, just please bear with me. And I think that as we go on, it'll make more and more sense. I really and truly believe that. So as it says, with inheritance, the dog class inherits from the animal class. So you could say that the animal class is known as the parent class, sometimes called the superclass, and the dog class in this instance would be the child class. All right? So this is known as the parent or superclass. This is the child or subclass in this case. Super, as it says, is the function we use to call methods of the parent. All right, as they mention here, super is particularly useful when you have a hierarchy of classes. So if we came in here and we added this, we added class puppy to dog. All right, and I'm going to add that in a second, but first, that's animal. Notice it says class dog, and in parentheses it says animal. This means animal, and this means dog is a child of animal. This means that puppy is a child of dog. So when we get done putting this one in, what this means is that the dog class will be both a child of animal and a parent to puppy. So we're starting to build what's referred to typically in here as a class hierarchy. Okay? So there's the next one. So we've got those three in here right now. Again, we're not creating any instances of this, so if we ran it right now, nothing's going to happen. All right, let's talk for a second about encapsulation. And I'm going to make a statement here that we live our lives in a very encapsulated way. All right, and what I mean is, going along with this, there are two terms that are very important. All right, and I'm going to use the same example that I've used in the classroom for many years. It might seem almost too simplistic, but I think hopefully at least it'll get the point across. And that is this. If I go up and I bring up the Windows calculator, all right, and if my goal is I want to know the square root of 1,367, so I put in 1367, I believe this is the one I use. All right, there it is. All right, so what does that have to do with these two words and with what we're talking about now? I want to mention it to you right this second. The interface is this. My calculator is the interface. When I bring it up, it looks like this. If I know how to use it, in other words, if I know I put in the number I'm looking for, and I hit this button, boom, it gives me the answer. So the interface is what the user can see. The implementation is what makes it work. I have no idea what's built into the calculator, into this calculator to make it work. All right. If for some reason, let's pretend for a second that when we do this, you notice we get the answer like that. But let's pretend for a minute that when we put in the number we were looking for and we hit that key, that it took 2 seconds before we got the answer. It doesn't, but we're going to pretend now that it does. All right, now somebody comes up with a new way of implementing a calculator where they cut it down from 2 seconds to half a second. If my interface doesn't change, I can put in a whole new implementation, because the implementation is what I don't see. It's what somebody else has created, and I just have to know how to use it. And where I said that this is a lot that we live our lives in an encapsulated or abstracted way. For instance, all right, I get up in the morning, get myself ready, etc. And let's say that on this particular day, I'm going to go get my oil changed for my car. So I get in my car, which is in my driveway. It's not backed in. So I put the car into reverse, look both ways, put it, start it up. Okay. What happens when I start it up? I don't know. I just know what happens if it doesn't start up. There's a problem. There's no gas, or there's a problem with the car. But when I go and shift the car, and it's an automatic on the floor, but when I move it from park to reverse, I don't know internally in the car what's happening to make that happen. I don't care. That's encapsulated from me. Now in here, they say encapsulation is the concept of restricting access to some things. All right, it says that you can restrict some of these things by using an underscore or a double underscore. You've already seen this one. All right, with that init. Now look at what's in here. Self dot underscore underscore name equal name. Self dot age equal age. All right. And we've got a get name and we've got a set name. Okay, what we're starting to talk about right now, just so you know, what we're starting to talk about right now, if you look at these two things that are in blue, are what are known as getters and what are known as setters. So what are these? A getter is called an accessor. So if let's say that I go into a meeting and I don't know anybody at this meeting. Let's say I'm going in for a job interview. All right. And I walk in there and I introduce myself. They ask me, they say, what is your name? And I say, hi, my name is Jeff Scott. Well, that's a getter. They are getting my name. They are accessing my name. Okay? And when you think about it, when I was born, when I was in the hospital, when I was first born, there probably was something like a piece of tape where I was in a crib and the nurse came up and said, what are you going to name him? And my mother said, we're going to call him Jeffrey Paul. So he'll be Jeffrey Paul Scott. There, I was setting my name. All right? When you do a get, it's called an accessor. A set is typically referred to as a mutator. Okay? Now, if we look here at this example, we've got self underscore underscore name as opposed to name. And notice it says here, by you putting in that minus minus, it's a private variable. If a variable is private, it can only be changed within the confines of the class itself. If a variable is public, which would be the opposite, so name is private and age is public, it can be changed from the outside. Again, this is just a lot to throw at you right now. I get that. All right? Okay. And they've got an example of a getter and a setter in here. We can put this in. I'm going to make another class in here. So let's again do a file, save all. Let's close the dog and let's close the animal. Let's come in and make a new one here. We'll call it dog2.py, and I'll just paste all that in. Now, if this works, this is right here. What are we doing? You should now know. Instantiating an instance of the dog class. Okay. And then in here, what are we doing? We are getting the value of that dog's name. All right. Here, we are setting, technically we're resetting, but we are setting the value of that dog's name. All right. And here we are once again getting the value of the dog's name. Now, if I did this right, what do we have here? We've got my dog equal Buddy3. So that's going to come up here. And we said Buddy, so that'll be the name. We said 3, so that'll be the age. Okay, that's what this does. Here, we're calling getName. So it should return this. So it should return Buddy. Then we're going back and we're resetting the name from Buddy to Max. And we're calling get again. So now instead of Buddy, it should say Max. So when I save and run this, it should show on the screen Buddy, and then underneath that, Max. And there it is. All right. Now, the next thing that's mentioned in here is something called polymorphism. All right. It's a Greek term, and it means many forms. All righty. Now, the key thing in here is this. Notice we've got a cat, which is another animal. We already did dog that was an animal. And now we've got cat that's an animal. And now we're coming in here and we're creating basically a list. We're saying we got a dog named Buddy that's 3 years old and a cat named Whiskers that doesn't have an age. All right. And it should print all this out. So let's grab this. In fact, we'll do it like this. I'm going to go back to this. We'll go back to this animal one that we had here. And I'm going to copy it, paste, and it's going to become animal 2. Okay, so that'll be animal 2. All righty. And now what I'm going to do is we've got all this dog stuff in here from before. Okay. And under the dog, I'm going to come in and I'm going to paste in this cat. Just this for right now. All right. Okay, so I've got in here, I've got an animal class, a dog class, and dog is a child of animal. We've got a puppy, which is a child of dog, and a cat, which is a child of animal. We're not printing anything out yet. We're going to do that in a second. All right. Now we're creating basically a new structure of dogs and cats. Now, who cares? Well, remember, the dog should say bark, but the cat should say meow if we did this correctly. All right, that's the key takeaway here. All right, so let's look. See if we've got a dog that says woof and a cat that says meow. And if we do, that's from right here. So let's remove this, and let's run this. Buddy says woof, Whiskers says meow. All right, why is that polymorphism? What the heck does that even mean? We're calling the speak method, but we defined speak in animal and we said pass. Remember, that means it's going to be defined elsewhere. So we define the speak method here. So it says woof. All right. And we define the speak method here. All right. And it says meow. Now, what if we came in? Notice we don't have a speak in here, but let's put one in. So we're going to put a speak method in here for the puppy. All right. And we'll have it say, instead of woof, it'll say woof, woof, woof. All right. Now we're going to come in here and we're going to create another thing in here. So we've got the dog Buddy, the cat Whiskers, and let's make in here a puppy. We'll call it Bingo. All right. And we'll make it 1 year old. All right. Hopefully I didn't screw this up, but we'll see right away whether or not I did. So you saw this. All right, now let's run it again. And of course we're getting an error. It says it's missing an argument called toy. What that means is, notice it needed a toy. Okay, we didn't give it a toy. And I'll give it one right now. And its toy will be a bone. Okay? So let's try it again. So now notice, Buddy says woof, Whiskers says meow, Bingo says woof, woof, woof. The point is this. All three of these classes have a method that is called speak. But each one of them speaks differently depending on the type of object that we passed to it. If we passed a dog, it says woof, a cat says meow, and a puppy says woof, woof, woof. All right? So when they put it all together, here's what they have. All right? So let's grab this whole thing, copy it, and I'm going to make an animal 3 here. So file, save, let's close this, let's make a new file here. So this will be, animal 3, 3.py. All right, let's paste that in. Now, since we do have this, they used Rex where I used Bingo. All right, but let's see what this one says now. All right, it says Buddy says woof, Whiskers says meow. Now we did not rewrite the speak method for a puppy, so it also says woof, and the puppy also plays with a ball. All right, so that was this first article. So let me do one more thing here. So that is, classes in Python are very easy. And we'll go to the first example that we had, which was, in fact, we'll put this in all of them. I don't know why, but we will anyway. right. And I'm going to say taken from the following article. There it is. Okay, and I'm going to grab this. I'm going to grab this and I'm going to copy it. Oops. All right, so this was in, there's a save all. So this was animal 3. I'm going to put it into the beginning of animal 2. Can't say that you're not, that I'm not letting you know what's what here. So that's animal 2. This is animal. So it's in there. So there's the animals. Here's the dog. And here's the other dog. Now, the idea behind this, again, was to just get you started. So I'm going to make a folder here that's going to be called Python Classes Are Easy. Okay, there's the folder, and I'm going to take everything that I have here. Oops, if I can. And I'm going to cut it and paste it. So it's now all in there. All right, so that's that first article. This took longer than I thought, but I'd rather have it take a little longer to have you understand what I'm going over. So when I come back with the next lecture, which will probably be tomorrow, but when I do, that one will be, so we've now gone over this one. Classes in Python are very easy, so I can get rid of that. And we're now going to go over this one. OOP in Python, Guide to Key Terms and Concepts. Much of it will be review from stuff we've already talked about, but we'll hit on all these. There's 12 terms in here. Functions, arguments, parameters, methods, attributes, encapsulation, abstraction, composition, inheritance, aggregation, overriding, and polymorphism. So we'll go through all these. And again, I will use their examples. When I get done with their example, I might even go and create one of my own. So that's it for right now. I'll be back with the next part, like I said, probably tomorrow. Okay, have a good evening.